Good day. I am Jay Manzano America, and I'm going to discuss the fifth week topic, which is sample and sampling. But first, we need to define sample. The fraction of the population being studied is called a sample. But why there's a need to find the sample? First is the cost. A sample often provides useful and reliable information at a much lower cost than a census. If we say census, it is a total official count of the population. Next, we have timeliness. A sample usually provides more timely information because fewer data are to be collected and processed. This attribute is particularly important when information is needed quickly. Here, it is quicker to get the needed information if we use a sample. The next one, we have accuracy. A sample often provides information as accurate and more accurate than census because data errors typically can be controlled better in smaller tests. Here, we can control or even eliminate the data errors which can lead into inaccurate results. So next, we have detailed information. More time is spent in getting detailed information with sample surveys than with censuses. In a census, we can often only obtain stocks but not flow data. For instance, agricultural production cannot be generated from censuses. In short, detailed information is better acquired in sample than in censuses. And the last one, we have destructive testing. When a test involves a destruction of an item, sampling must be used. If we're going to eliminate or decrease an item, sampling should be used, or sampling is better used. So now we are done in giving some reasons why we need to find the sample. So next, we have to know about the types of sampling. First, probability sampling. So here, if data is to be used to make decisions about population, then how the data is collected is critical. For example, data to provide reliable information about a population of interest, the sample must be representative of that population. Selecting sample from the population using chance allows the samples to be representative. In short, probability sampling means that every member of the population has a chance of being selected. So next, we have the basic types of probability sampling. So first, we have simple random sampling, or SRS. It involves allowing each possible sampling to have an equal chance of being picked, and every member of the population has an equal chance of being included in the sample. So it could be with replacement or without replacement. With replacement, selected individual or unit is returned to the frame for possible reselection. But in without replacement, the selected individual or unit is not returned to the frame. So this sampling method requires a listing of all the elements of the population called sampling frame. And next, we have stratified sampling. It is an extension of simple random sampling which allows for different homogeneous groups called strata. Here, to obtain a stratified sample, the population is divided into two or more strata based on common characteristics. If so, common characteristics, these are the similarity for each groups in a certain strata. And simple random sampling is used to select from each strata with sample sizes proportional to the strata sizes. Samples from the strata are then combined into one, and this is a common technique when sampling from a population of voters stratifying across a racial or socioeconomic classes. Next, we have systematic sampling. In systematic sampling, every elements are selected from the population at a uniform interval that is measured in time, order, or space. If we say uniform interval, there is an equal interval or range for each selected representative or respondents. The first representative or respondent must be selected randomly. So next, we have the cluster sampling. Here, it divides the population into groups called clusters. Here, with the use of simple random sampling, whole cluster is selected randomly and all of the members of the cluster are subjected as the sample or representative of the whole population. So next, we have the non-probability sampling. We say non-probability sampling or the judgment sampling. It is the generic name of the several sampling methods where some units in the population do not have the chance to be selected in the sample, or if the inclusion probabilities cannot be computed. So here we're going to have some examples of non-probability sampling. First, we have the haphazard or accidental sampling. It involves an unsystematic selection of sample units. Yes, it is the opposite of systematic sampling. Some disciplines like archaeology, history, and even medicine draw conclusions from whatever items are made available. Some disciplines like astronomy, experimental physics, and chemistry often do not care about representativeness of these specimens. So next, we have convenience sampling. Sample units expedient to the sampler are taken. So here, you can select your sample respondents to the extent to which you are convenient with. For example, your friends or anyone who are more accessible. So next one we have volunteer sampling. If you say volunteer sampling, sample units are volunteers in studies wherein the measuring process is painful or troublesome to the respondents. So here, whoever volunteers to be respondents or your sample if they are not, even if they are not suitable as your representative. So here, you can have bias or inappropriate or inconclusive result. So next one, we have purposive sampling. So here it pertains to having an expert select or representative sample based on his own subjective judgment. So here, whoever qualifies to the categories are your samples. So next one, we have quota sampling. Here, sample units are picked for convenience, but certain quotas are given to interviewers, such as the numbers of persons to be interviewed. So this design is especially used in market research. So here, if you're going to have a specific number. If you already met that needed number, then you're done in selecting your samples. So last one is noble sampling. Here, additional sample units are identified by asking previously picked sample units for people they know who can be added to your sample. Usually, this is used when your topic is not common or the population is hard to access. Here, you're going to ask your previous respondent if they know someone who can be your additional respondent. So next, we're going to differentiate the parameter in statistics. So here, parameters are the numbers that summarize or describe the data for an entire population. So here we have mean, the Greek letter mu, variance, the Greek letter sigma squared, and for the standard deviation, we have the Greek letter sigma itself. For statistics, these are the numbers that summarize data from a sample. For the mean, it is the x bar. Variance, it is the small letter s then squared. Standard deviation is the small letter s itself. So in short, parameters describes the populations or population, and statistics describes the sample. Again, parameters, population, statistics, sample. So next we have sample mean. So what is sample means? The sample mean or X bar from a group of observation is an estimate of the population. So meaning, sample mean can substitute the value of the population mean. So with the use of sample mean, you can conclude about the population or the average of the population. So we have the formula X bar is equal to 1 over n times the sum of the values of the observation. So that's it. So thank you and good luck.